Hey all, so now we are going to talk about acceleration for motion in a straight line, right? So what is acceleration? Acceleration is something related to something related to the as its word suggests, right? It is something to accelerate or increase, right? So what does it do? What does it do basically? The acceleration. It is nothing but the rate of change of velocity. Means how velocity increases with time. It is as accelerate, as I said, it is increase of something. It is increase of nothing but the velocity, right? So it's a vector quantity, and it represents the increase on velocity with respect to time. Right? So how you write it? If you are writing acceleration as a, it's a vector, so nothing but change in velocity, which is v divided by delta t. So if you take a vt graph, if I say it is something like this, as we discussed in the velocity and instantaneous and average velocity in the earlier case. Here v and t, if you have a graph like this, then you will observe that the discrete velocity represents nothing but the 2 points pq represented by t1 and t2, t1, t2, t, and v1 and v2, p2 and v1. Right? So this is something you must remember. So this is, what does it represent? It represents your average velocity. Sorry, average acceleration. Same like average velocity we discussed. So average acceleration, this is average acceleration, right? Now what is instantaneous acceleration? It is same as you define it a dash, and it is nothing but the limit delta t goes to 0 del v by del t. Remember that it is same as we discussed in the average velocity and instantaneous velocity. So here when delta t, the time interval, goes to 0, then change in velocity is nothing but the acceleration in that time interval. So basically it is changing from the discrete to the continuous system. Again, to discreteness to continuousness. This is what it does, right? So instantaneous acceleration is there. So instantaneous acceleration is very intervals goes smaller and smaller and smaller. When it becomes so small that again it is tj minus ti, you define a delta tij ji, right, where j is always greater than I, right, so which represents the position of velocities and times at, right. So this tj minus ti is so tj ti for j greater than I must be very greater than delta tij, tji, right, where it can be understood if motion is in straight line, then ti is here and tj is here, very close to each other, and this interval is very small, delta tji, right, as it is infinitesimal. So this This is what we call, so it can be neglected compared to Ti and Tg. Right? So this is what we call the acceleration. Now let us discuss the acceleration. What is acceleration, what is deceleration, and xt graph and vt graph. So different kind of graphs are there. So right. So acceleration, and actually acceleration is something which is associated with positive increase in the velocity, whereas the deceleration, or called retardation, which is basically called decrease in the velocity with respect to time. Right? It is called the retardation. Right? So you can understand it as a negative of acceleration. So now let us discuss about the x and t graph. How does it look like when for a accelerating and deaccelerating or constant or zero acceleration system? So xt graph for acceleration, retardation, and constant velocity, which means the zero acceleration. Right? So first graph will be something like this. Right? This is called xt graph. Now what you will observe, that it increases. It increases as you, so initially it starts at certain point, right, and as time passes, this this increases, right? So it is related to basically you can understand it by the relation between the displacement and acceleration. So x equals to, if you recall the usual relation, ut plus half at square, right? So how, if acceleration is positive, then graph is more like a parabola, for a parabola. Its x is proportional to t square for a so if x and t graph is there, then how it will look like? It will look like something like this for a positive acceleration. Right? Then you can go to negative acceleration case. Sorry. It will look like something like this. Right? Negative slope. So it is basically just going down. Right? Now what is the constant velocity case? The constant velocity case, you will observe no change. It will look like something like a straight line, right? Which is not like that basically. So remember that this is that was for velocity time. Now this position time graph will be a straight line, which is this part, x equals to ut. Right? Remember that. So which passes through the origin, right? Y equals to mx plus c. Now c is 0 in this case, as acceleration is 0, right? So c is 0, and this, so it means that x equals to ut, straight line passing through the origin. That's a constant potential, a constant zero acceleration case. The positive acceleration case, the graph will look like something, and when negative is there, then it will be ut minus half at square. So it decreases. So this case is there, right? So it's a sum of linear, and so it's a parabolic in the nature. Remember that. It's a parabolic graph. So it looks like something for positive, for negative, and for zero acceleration case, xt graph. So now we will go to another case. Let me remove this. What we call velocity time graph for different accelerations, right? So let us talk about velocity time graph, right? So let us start with the velocity time graph first. Right, for different cases when your A is positive, right, it is accelerating system. So if you remember carefully, what is the accelerating system? It means that if system is accelerating, it means velocity increases with the time, right? So let us assume that it is not starting from 0 rather than some v0 at the velocity, and this is v, right, and this is time. Then you will observe that velocity time graph will look like something like this, right? So what it is doing is basically it is increasing, right? It is increasing. So this is your time, and this represents the velocity. So initially you have v naught, and after some time, at time t, like here t equals to 0, and at t, here it is v. This point is basically vt, right? This is v0, 0. If you are taking xy, it will be 0, v0, 0, v0, and t, vt, right? So this is your, and this is the area, right? So this is your velocity type for positive accelerating system. Now what happens when your body is negatively accelerated and starts with a positive velocity? Yeah, we are talking about the positive velocity. V naught is greater than 0, right? So now when A naught is less than 0 and V naught is greater than 0, right? So what is this case? This is de-accelerating system. This was V equals to U plus AT, or sorry, V naught plus AT. Started from V naught with constant slope of with respect to t, which is A. The slope is represented by A, right? So this slope is represented by A, and here it is de-accelerating system, and V naught is greater than 0, and A naught is basically, or A, sorry, A, not V naught, A. So what happens? It starts with a certain velocity V naught here and goes to certain velocity V here with time, right? As time passes, it decreases, right? So you will see at t equals to 0, you will have V naught. So 0 V naught as the initial coordinate, and the final coordinate will be here. What is it? It is simple. It is Vt. Here it is, here V, here it is t. It is V naught 0. So this Vt is there. Now this part is representing your a less than 0, right? And how it is? V equals to u v naught minus at, right? So this is what you are getting. Remember that this is all vector. Right, is except t. So this is there. So this is these are the two graphs. Now we'll discuss other cases also. Now let us take another case of right, another case of moves in negative direction with negative acceleration, right? V naught is negative. So in negative direction, negative acceleration, Vt graph. So you start with some negative value of V naught and you go to this further decreasing, right? You can think of it as t, right? So this is negative of v naught and this is negative of v. This relation is there with a. It is decreasing, right? As it is negative but comparatively positive with respect to this. So comparatively higher. You know that if you recall the real number line, the point on the negative side of the number line are basically defined in that order. The point which are closer to the 0 have greater values than those which lies away from the 0. So this is having a lesser value than this one. So that is how we are talking about deceleration, right? So minus v is nothing but minus of v naught minus of at, right? So this is called in negative direction with negative acceleration. Now let us take another case where basically, this is third one and this is fourth one. When particle changes direction, it moves with the positive and then after some time t, it changes to, it is deaccelerating, right? And then up to t1 and then from there basically let me so up to t1 it starts from some v naught and goes up to t1 where it becomes 0, right, deaccelerating, right, and then goes to negative direction up to t2 with same value. Basically it changes direction here, right? It becomes v minus v, right? So it is changing with same slope in negative direction, right? Starts with the v naught, goes to the 0 and then it is just like you have a target here and then you go, you touch it, you start and you come back. So you just go, you deaccelerate here, it becomes 0 and then you again start accelerating, right? Basically rate of change of velocity is same in both the cases. So here, so it is like that. So here at t1 it is changing the direction and t2 you have this v. So this is your velocity time graph. Now let us take a constant acceleration graph in this case. So what is the constant acceleration graph? So constant acceleration graph is the one, constant velocity graph and zero acceleration graph. In xt we discussed it is a straight line. In vt, so it is whenever it is asked to draw a graph or just check the graph whether it is correct or not, or you want to deduce anything from the graph, you always recall the relation between those quantities. If you remember the relation, it will be easier to draw the graph. You can take two random points and you can 2-3 random points, and you can easily draw the graph using the relation between them. So this velocity and acceleration, which is a linear relation, right? V naught plus at, right? Now what happens if it is a constant t, right? It is u. Now what is this graph? U and t, your velocity is there, time is there. It is nothing but, if you look at it carefully, it gives you encloses an area. Now if you look at it carefully, very carefully, what does it shows? It shows that velocity doesn't vary with time. So whatever the time is there, it is always the u. U is here, 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 here. At each point it is u, right? So at each point it is u. It means that velocity v equals to u, means it's a constant accelerating graph. So whichever initial value it starts with, it remains at the same value. It doesn't change with time. So this is what we call a velocity time graph, or constant or basically constant velocity graph, or zero acceleration, a equals to 0 case, zero acceleration graph, right? So this is zero acceleration graph is there. Now one important thing, whenever we are drawing the graph, we take sharp corners. It means, what does it mean in the graph? It means that it's sharp, a quantity has a discontinuity at that point, but that is not true. Remember that it's not the sharp variation, and the actually the all quantities which we are taking here are continuous. So LHL equals to you, if you recall that continuity condition, left hand limit equals to right hand limit, right? So you take t minus some delta t to t plus delta t, right? Where delta t goes to 0, it will remain equal, right? So this is something you must not forget. So all the quantities at the extreme, these sharp corners are continuous. So these are actually not the sharp corners. So there is a continuous variation, right? So this is one must remember and do not confuse. So this is all we have in the acceleration for a particle in a straight line motion, right? So now we will discuss some of the problems in the in next lecture. Please note it down. If you have any queries, please do comment in the comment section. We are always looking forward for your comments, and will be very eager to answer any of the questions coming from your side, right? So please go through the lectures, and you can also look for some of the books on the course to understand it in a deeper way. If required, I can always recommend it to you. Thank you.